You've probably seen those images, the ones NASA released. Blurry, pixelated, barely distinguishable shapes floating against the darkness of space. And if you're like millions of others who've stumbled across them, you've probably asked yourself the same question. Why? Why would the most advanced space agency in human history release images that look like they were taken on a phone from 2005? It's 2025. We've sent rovers to Mars. We've captured black holes in stunning detail. We've photographed galaxies billions of light years away with crystalline clarity. Yet when it comes to 3i Atlas, an object that passed relatively close to our planet, all we get are blurry, inconclusive pictures that raise more questions than they answer. And here's the thing that should make you pause. This isn't just odd, it's unprecedented. Never before has NASA released imaging of such poor quality for an object of this significance without a comprehensive, transparent explanation. That silence, that's what fuels the fire. Now, I'm not here to tell you what to believe. I'm not here to spin conspiracy theories or feed you sensationalized nonsense. What I am here to do is walk you through the facts, the questions, the claims, and the science. Because the truth, whatever it is, deserves more than blind acceptance or knee-jerk dismissal. It deserves investigation, and that's exactly what we're going to do together. Over the next several minutes, we're going to dissect every angle of this story. We'll examine what 3i Atlas actually is, why the images are so frustratingly unclear, what NASA has said and hasn't said, and why so many people believe there's something more to this story than simple technical limitations. We'll look at the scientific community's response, explore the speculative theories circulating online, and discuss what this all means for transparency in space exploration. Stay with me, because in this video, we're going to uncover whether NASA's blurry 3i Atlas photos are the result of unavoidable technical challenges or if there's a deeper reason the public is being kept in the dark. And by the end, you'll have all the information you need to draw your own informed conclusions. But before we dive in, let me be clear about something. This isn't about attacking NASA or any space agency. These organizations have given humanity some of the most profound discoveries in our history. This is about asking the right questions. It's about recognizing that when information is withheld or unclear, curiosity isn't conspiracy, it's responsibility. And as citizens of a world increasingly dependent on space exploration and the data it provides, we have every right to demand clarity. So here's what bothers people. Here's what keeps this story alive in forums, in comment sections, in late-night conversations among space enthusiasts. It's not just the blurriness, it's the inconsistency. It's the fact that we've seen NASA produce breathtaking images of objects far more distant and far less significant. It's the fact that 3i Atlas, an interstellar visitor that offered a rare opportunity to study material from beyond our solar system, was treated with what seems like photographic indifference. And when people ask why, the answers they get feel incomplete, evasive even. That's where doubt creeps in. That's where questions become suspicions. Now some will say this is all overblown, that people are seeing patterns where none exist, that technical limitations are just that, limitations and nothing more. And maybe they're right, but maybe they're not. And the only way to know is to look at the evidence, to weigh the explanations, and to think critically about what we're being told versus what we're being shown. Because in the age of information, the biggest threat isn't misinformation, it's the refusal to question at all. Think about it. When something doesn't add up, your gut knows it. You feel it. That nagging sense that there's more to the story, that's not paranoia, that's pattern recognition. It's your mind connecting dots, identifying inconsistencies, and demanding resolution. And when those inconsistencies involve something as monumental as an object from another star system, the stakes feel even higher. Because if we can't trust the clarity of images from our own space agencies, what can we trust? If the organizations tasked with expanding human knowledge are providing us with unclear, unsatisfying data, what does that say about transparency, about accountability? These are uncomfortable questions, but they're necessary ones, and they're the questions we're going to explore together, not with blind skepticism, but with informed curiosity. We're going to approach this the way any good investigation should be approached, by laying out the facts, examining the claims, considering the context, and refusing to accept easy answers when hard questions remain. Because the truth, whatever it is worth the effort. And you, as someone who cares enough to be here, To watch this, to engage with this topic, you deserve more than surface-level explanations. You deserve depth, you deserve honesty, and you deserve the full picture. So if you're ready to go deeper, if you're ready to question, to think, to explore this mystery with an open mind and a critical eye, then do me a favour. Hit that like button right now. Not because I'm asking for it, but because it tells me you're here for the real conversation, the one that doesn't shy away from difficult questions. And drop a comment below telling me where you're watching from, and whether you think NASA's blurry images are just a technical issue or something more. Because this isn't just my investigation, it's ours. And I want to hear what you think. I want to know if you've seen these images, if you've had the same questions, if you've felt that same unease. Let's build this conversation together. Because the more voices we have, the harder it becomes to ignore the questions that matter. Now let's get into it. Let's start with the basics, because before we can understand why the images are blurry, we need to understand what we're actually looking at. So let's talk about what we're actually dealing with here. The images in question, the ones that have sparked so much debate and suspicion, are photographs taken of 3I Atlas, an interstellar object that travelled through our solar system. Now, you already know the significance of an interstellar visitor. These aren't asteroids from our asteroid belt or comets from our Kuiper belt. These are objects that originated outside our solar system, beyond the gravitational influence of our Sun, from regions of space we can only dream of studying up close. They carry with them material, composition, and potentially information from other star systems. They are, in the most literal sense, messengers from the cosmos. And when one passes through our neighbourhood, it's a big deal, a huge deal. But here's where things get frustrating. When NASA and other observatories released images of 3I Atlas, the public expected something spectacular, something clear, something that would allow us to see the structure, the shape, the surface details of this cosmic traveller. Instead, what we got were images that looked, frankly, terrible, blurry, grainy, low resolution to the point of being almost useless for visual analysis. You could barely make out a defined shape. It looked more like a smudge on a telescope lens than a historic interstellar object. And immediately people started asking, why? Now, let's be clear about what these images actually show, or rather what they're supposed to show. The photographs were taken using ground-based and space-based telescopes as 3I Atlas passed through the inner solar system. The object itself was moving at incredible speed, as interstellar objects do, and it was relatively small, not planet-sized, not even particularly large by comet standards, but it was within range, within the reach of our most advanced imaging technology, and yet the images we received didn't reflect that advanced capability. They reflected something far less impressive, something that, to the untrained eye and even to many trained eyes, seemed inadequate. But what exactly are we looking at in these images? What should we be seeing? Well, ideally we'd see surface features, texture, shape definition. We'd see whether the object is elongated or spherical, rough or smooth, cratered or pristine. We'd see the activity if it's outgassing, the tail if it's comet-like, the rotation if it's tumbling through space. These are the details that scientists need to understand what 3I Atlas is made of, where it came from, and what it can tell us about the interstellar medium. These are the details that should be visible with the technology we have. And in many other cases they have been, but not here, not with 3I Atlas. So what do the images actually reveal? Very little. They show a bright point of light, sometimes elongated, surrounded by a faint glow. There's some suggestion of a coma, the cloud of gas and dust that typically surrounds a comet, which indicates that 3I Atlas was indeed active and outgassing as it approached the Sun. But beyond that, nothing definitive, nothing that allows for detailed morphological analysis, nothing that satisfies the basic expectations of modern astronomy. And that's the problem. Because when an object this rare, this scientifically valuable, passes through our solar system, we expect better. We expect NASA and the global astronomical community to prioritize capturing the best possible images. And when that doesn't happen, or when it appears not to happen, people wonder why. Now, some have pointed out that not all images of 3I Atlas are equally blurry. Some observations, particularly spectroscopic data, provided useful information about the object's composition. Scientists were able to determine that it contained organic molecules, water ice, and other materials consistent with cometary bodies. That's valuable. That's scientifically significant. But spectroscopy and direct imaging are two different things. One tells you what something is made of, the other tells you what it looks like. And when it comes to public perception, when it comes to satisfying curiosity and building trust, images matter. People connect with images. They want to see what we're talking about. They want visual confirmation. And when that visual confirmation is denied, whether intentionally or not, it breeds doubt. And here's where the psychology of this becomes fascinating. Humans are visual creatures. We trust what we can see. We feel more certain, more grounded, when we have a clear picture in front of us. It's why eyewitness testimony, despite its flaws, carries so much weight. It's why photographs are considered evidence. It's why seeing is believing. So when NASA, an organization we've come to rely on for stunning detailed images of the cosmos, releases something that looks like it was taken through a foggy window, it doesn't just disappoint. It raises alarms. Because our brains are wired to ask, if they can show us the rings of Saturn in exquisite detail, why can't they show us Three-Eye Atlas with even basic clarity? And that question, that simple, reasonable question, is at the heart of this entire controversy. It's not about demanding perfection. It's about expecting consistency. It's about recognizing that when there's a significant gap between capability and output, there should be an explanation. A thorough, transparent, understandable explanation. And for many people, that explanation hasn't been provided. Or if it hasn't been convincing. So what are people seeing when they look at these images? They're seeing ambiguity. They're seeing an object that could be almost anything. A rock, a ship, a cluster of smaller objects, a deliberately obscured structure. And in that ambiguity, the imagination fills the gaps. Speculation takes root. Theories emerge. Not because people are irrational, but because the human mind abhors an information vacuum. When we don't have clear answers, we create them. And the more unclear the official narrative, the more creative those unofficial narratives become. But let's not get ahead of ourselves. Before we dive into the speculation, before we explore the theories and the claims, we need to understand the baseline. We need to know what NASA has actually said about these images. What are the technical challenges? What are the limitations? What are the reasons, according to the official sources, that these images turned out the way they did? Because if there are legitimate, understandable reasons, then that changes the conversation. It doesn't eliminate curiosity, but it grounds it. It gives us a starting point for evaluation, and that's exactly where we need to go next. We need to understand the technology, the constraints, and the official explanations before we can assess whether those explanations hold up under scrutiny. Because only then can we determine if the blurriness is truly unavoidable or if there's something else at play, and that's the question we're here to answer. Let's talk about the technical side of this, because if we're going to be fair, if we're going to approach this with intellectual honesty, we have to understand the limitations that NASA and other space agencies operate under. We have to acknowledge that space is hard, that capturing clear images of distant, fast-moving objects is incredibly challenging, that even with the best technology humanity has ever created, there are constraints. Physics doesn't bend to our desires. Light has a speed limit. Telescopes have resolution limits. And when you're trying to photograph something millions of miles away, moving at speeds we can barely comprehend, things get complicated. So what has NASA actually said about these images? What are the official explanations for why Three-Eye Atlas appears so blurry? Well, according to NASA and the broader astronomical community, there are several factors at play. First, distance. Even though Three-Eye Atlas passed relatively close to Earth by astronomical standards, it was still incredibly far away. We're talking tens of millions of miles at its nearest approach, and at that distance, even large objects appear as tiny points of light. To resolve surface details, to see structure and texture, you need either a much closer approach or telescopes with extraordinarily high resolution. And while we do have high-resolution telescopes, they have their limits. Second, speed. Three-Eye Atlas was moving fast. Interstellar objects don't leisurely cruise through the solar system. They zip through at velocities that make even the fastest human-made spacecraft look sluggish. This creates a motion blur problem. When an object is moving quickly relative to the observer, capturing a sharp image requires very short exposure times. But short exposure times mean less light collected, which means fainter images. It's a balancing act. You need enough exposure to gather sufficient light to see the object, but not so much that the motion smears the image into an unrecognizable blur. And finding that balance, especially with a small, faint object, is extraordinarily difficult. Third, brightness. 3i Atlas wasn't particularly bright. It reflected very little sunlight because of its size and composition. Faint objects require longer exposure times to capture, but as we just discussed, longer exposures introduce motion blur. So you're caught in a technical trap. You need more light, but gathering more light degrades the sharpness. It's a fundamental challenge in observational astronomy, and it's not unique to 3i Atlas. Every astronomer who's ever tried to image a fast-moving distant object has faced this same problem. Fourth, the equipment itself. Not all telescopes are created equal. Ground-based telescopes have to contend with Earth's atmosphere, which distorts incoming light. Even with adaptive optics, which compensate for atmospheric turbulence, there's a limit to how sharp ground-based images can be. Space-based telescopes like Hubble avoid this problem, but they have limited observation time and must prioritize targets. Hubble, for instance, has a packed schedule. It's constantly booked for observations of galaxies, nebulae, exoplanets, and countless other targets deemed scientifically valuable. Getting time on Hubble to image a single interstellar object, especially one that's only visible for a short window, is a logistical challenge. And even if time is allocated, the object might not be positioned optimally for observation. Timing, alignment, and availability all play a role. Now, these are legitimate technical challenges. They're not made up. They're not excuses. They're real constraints that astronomers deal with every single day. And if we're being fair, we have to acknowledge that. We have to recognize that NASA isn't sitting on some magical camera that can photograph anything, anywhere, anytime, with perfect clarity. Technology has limits, physics has limits, and those limits don't disappear just because we want them to. But here's where the doubt creeps in. Here's where the questions become harder to dismiss. Because while all of these technical challenges are real, they're not unprecedented. NASA has imaged fast-moving, distant, faint objects before. They've done it with comets. They've done it with asteroids. They've done it with moons of distant planets. And in many of those cases, the results have been far clearer than what we've seen with 3i Atlas. So the question becomes, why was this object treated differently? Why weren't the same resources, the same prioritization, the same technical solutions applied here? Was it simply a matter of unfortunate timing? Bad luck with observation windows and telescope availability? Or was there a deliberate choice to deprioritize high-resolution imaging of this particular object? And this is where NASA's image release policy becomes relevant. Because NASA doesn't just take pictures and immediately post them online. There's a process. Images are processed, analyzed, sometimes enhanced, sometimes calibrated for scientific use, and not all images taken are released to the public. Some remain internal, used only by researchers. Some are deemed too low quality to be worth releasing. Some are embargoed until research papers are published. There's a whole infrastructure around what gets released, when and in what form. And that infrastructure, while necessary for scientific rigor, also creates opportunities for selectivity, for choices about what the public sees and what they don't. Now, I'm not saying NASA is deliberately hiding clear images of 3i Atlas. I'm not saying there's a vault somewhere filled with crystal clear photographs that have been withheld from public view. What I am saying is that the process itself is opaque. The public doesn't know what other images exist. They don't know what was captured but not released. They don't know whether there were opportunities for better imaging that were passed over. They simply see the end result, the blurry images, and they're told, this is the best we have. And when people don't have transparency, when they don't have insight into the process, they fill the gaps with doubt. And that doubt is compounded by precedent, because we've seen, in other contexts, how selective image release can shape public perception. We've seen how military organizations, intelligence agencies, and even scientific institutions have withheld information for various reasons, some legitimate, some less so. We've seen how blurry UFO footage, released by the Pentagon, sparked global conversation and speculation because the lack of clarity left room for interpretation. We've seen how ambiguity, intentional or not, fuels curiosity and suspicion, and when that same pattern emerges with something as significant as an interstellar object, people naturally wonder if history is repeating itself. So what's the truth? Are NASA's blurry images of 3i Atlas simply the result of unavoidable technical limitations? Or is there more to the story? That's what we're trying to figure out. And to do that, we need to look at what people are claiming. We need to examine the theories, the speculation, the accusations that are circulating online and in space enthusiast communities. Because those theories, whether grounded in fact or not, reveal something important. They reveal a gap between public expectation and institutional delivery. They reveal a hunger for transparency that isn't being satisfied. And they reveal that when it comes to interstellar visitors, the stakes feel higher, the questions feel more urgent, and the answers feel more elusive. So let's turn our attention now to the claims themselves, to the voices saying that NASA's blurry images aren't just a technical issue but a deliberate act of concealment. And let's evaluate those claims with the same critical lens we've applied to everything else. This is where things get interesting. This is where the conversation shifts from technical limitations and procedural explanations to something far more provocative. The possibility that NASA's blurry images of 3I Atlas are intentional, that they're not the result of unavoidable constraints but deliberate choices, that there's something about this object, something significant, that NASA doesn't want the public to see clearly. And before you dismiss this as fringe conspiracy theory, before you write it off as the ramblings of paranoid internet commenters, consider this. The people making these claims aren't all uninformed. Some are engineers, some are scientists, some are space enthusiasts with decades of experience analysing astronomical data. They're not asking these questions out of ignorance. They're asking because they've looked at the evidence, or lack thereof, and something doesn't sit right. So what exactly are these claims? What are people saying? Let's start with the most common assertion, that NASA deliberately released low-quality images to obscure the true nature of 3I Atlas. The argument goes something like this. NASA has access to far better imaging technology than what was used, or at least what was shown, for 3I Atlas. They have relationships with observatories around the world, access to advanced space telescopes, and the expertise to prioritize high-value targets. An interstellar object passing through our solar system is, by any measure, a high-value target. It's a once-in-a-lifetime observation opportunity. So why, these critics ask, would NASA settle for blurry, inconclusive images when they had the means to do better? The implication is clear. They didn't settle. They chose. They chose to release poor-quality images because clear images would reveal something they don't want revealed. But what could that something be? What could possibly be so significant that NASA would risk public trust and scientific credibility to keep it hidden? This is where the speculation branches into multiple directions, some more grounded than others. One popular theory is that 3I Atlas isn't a natural object at all, that it's artificial, that it's a probe, a craft, maybe even a derelict ship from an alien civilization. Now, I know that sounds sensational. I know it sounds like science fiction. But consider this. We've never had an interstellar object stay in our system long enough to study in detail. We've had Oumuamua, and it raised eyebrows for its unusual elongated shape and acceleration that couldn't easily be explained by outgassing alone. Then came 3I Atlas, and immediately people started wondering if we were seeing another anomaly, another object that defied easy categorization. And here's the thing, if NASA suspected, even remotely, that an object might be artificial, would they tell us? Would they release that information before they were absolutely certain? Or would they withhold, study in private, and only reveal once they had irrefutable proof? Because imagine the global reaction if NASA announced prematurely that they believed an alien probe had entered our solar system, only to later retract that claim. The credibility damage would be immense. The public panic, depending on how it was framed, could be significant. So there's an argument to be made that even if NASA suspected something unusual, they would be extremely cautious about what they shared and when. Another theory, slightly less sensational but still provocative, is that 3I Atlas is indeed a natural object, but one with unusual properties or composition that challenges our current understanding of interstellar matter. Maybe it's made of materials we've never encountered. Maybe its structure suggests formation processes we don't yet understand. Maybe there's something about its trajectory, its behavior, its spectroscopic signature that doesn't fit neatly into existing models. And if that's the case, NASA might be reluctant to release detailed images until they've had time to analyze, to theorize, to understand what they're seeing. Because releasing data that contradicts established science without context, without explanation, can lead to misinterpretation. It can fuel misinformation. And in an era where scientific literacy is already under siege, That's a legitimate concern. Then there's the simpler, more cynical theory that NASA is just covering their own inadequacy, that they failed to prioritize 3i Atlas properly, failed to allocate sufficient resources for imaging, and now they're releasing blurry photos as a way to avoid admitting that they dropped the ball, that they're embarrassed, that the blurriness isn't hiding something extraordinary, just their own lack of preparation. And while this theory lacks the drama of alien probes and exotic materials, it's arguably more plausible. Because bureaucracies make mistakes, resources get misallocated, opportunities get missed, and when that happens, the instinct is often to downplay, to excuse, to avoid accountability. But regardless of which theory you find most compelling, the underlying sentiment is the same. There's a lack of transparency. There's a gap between what people expected to see and what they were shown. And in that gap, suspicion grows. Because when information is withheld, when explanations feel incomplete, the human mind defaults to worst-case scenarios. It's a survival mechanism. We're wired to be cautious, to assume danger when uncertainty is present. And while that served our ancestors well when dealing with predators and unfamiliar terrain, it can lead to overreaction and unfounded suspicion in modern contexts. But it can also, sometimes, lead to legitimate discovery, to uncovering truths that institutions would prefer to keep hidden. So where does the evidence actually point? Are there any credible indicators that NASA is hiding something? Well, let's look at patterns. NASA has a long history of transparency, but also a history of selective disclosure. They release vast amounts of data to the public, but not everything. Some information is classified for national security reasons, some is withheld pending peer review, some is simply deemed not ready for public consumption. And that's not unique to NASA. Every scientific institution operates this way. But it does mean that public access to information is filtered, it's mediated, and that mediation, necessary as it might be, creates room for doubt. There's also the issue of timing. The images of 3i Atlas were released relatively late in the observation window. By the time the public saw them, the object had already moved on, no longer in optimal position for detailed study. This has led some to question whether the delay was strategic, whether NASA waited until the object was out of range before releasing images, specifically to avoid further public scrutiny or demands for better photographs. Again, this could be entirely innocent. Processing takes time, analysis takes time, but the perception of delay, especially when paired with low-quality images, feeds the narrative of concealment. And then there's the response, or lack thereof, from NASA to public questions. When people ask why the images are so blurry, the answers they receive are often technical, jargon-heavy, and difficult for non-experts to pass. That's not necessarily intentional obfuscation, but it has that effect. It creates a barrier between the public and the information they're seeking. It makes people feel like they're being talked down to, or worse, deliberately confused. And when people feel that way, they stop trusting. They start assuming that if the explanation were simple and honest, it would be communicated simply and honestly. The fact that it's not, in their view, suggests there's something to hide. Now, I want to be very clear here. None of this is proof of a cover-up. None of this definitively demonstrates that NASA is hiding the true nature of 3i Atlas. What it demonstrates is that there's a perception problem, a trust problem, a communication problem, and those problems, whether rooted in legitimate grievances or simple misunderstanding, have real consequences. They erode public confidence, they fuel conspiracy theories, and they make it harder for NASA and other institutions to do their work effectively. Because science depends on public support, it depends on funding, on political will, on a citizenry that believes in the value of exploration and discovery. And when that belief is undermined by perceptions of secrecy, everyone loses. So what's the solution? More transparency, more communication, more willingness to engage with public questions, even when those questions are difficult or skeptical. Because the alternative is, what we're seeing now, a growing divide between institutions and the people they serve, a divide that benefits no one and harms everyone. And as we move forward, as we continue to explore this mystery, we need to keep that in mind. We need to demand better, not out of hostility, but out of a genuine desire for truth, because the truth, whatever it is the only foundation on which trust can be rebuilt. And that brings us to the next critical piece of this puzzle. What does the scientific community actually say about all of this? How do astronomers, researchers, and experts respond to these claims, and do their explanations hold up under scrutiny? Let's find out. When controversy erupts in the public sphere about a scientific matter, the scientific community typically responds. Sometimes quickly, sometimes slowly, but they respond. Because scientists, despite the stereotype of being detached and ivory-towered, care deeply about public understanding. They care about their work being represented accurately. And they care, perhaps more than anything, about defending the integrity of the scientific process. So when claims started circulating that NASA's blurry images of Three-Eye Atlas were evidence of a cover-up, astronomers and researchers around the world began weighing in. And their responses, predictably, range from patient explanation to exasperated frustration. But the core message was consistent: there's no conspiracy. The images are blurry because of technical limitations, not deliberate concealment, and anyone with a basic understanding of observational astronomy would recognize that. So let's walk through their arguments, because they deserve a fair hearing. First, astronomers emphasize the sheer difficulty of imaging small, fast-moving interstellar objects. They point out that even with our best telescopes, resolving surface details on an object the size of Three-Eye Atlas at the distances involved is nearly impossible. It would require, in the words of one astronomer, a telescope the size of a small country. The resolution needed to see fine details simply isn't available with current ground-based instruments, and space-based telescopes like Hubble, while powerful, have narrow fields of view and limited availability. Three-Eye Atlas was observed, but capturing highly detailed images within the narrow time window it was close enough to be visible was a logistical and technical challenge that no amount of wishful thinking could overcome. Second, scientists point to the wealth of data that was actually collected on Three-Eye Atlas. While the images might be blurry, the spectroscopic data is rich and informative. Astronomers were able to analyze the light reflected and emitted by the object, determining its composition with a high degree of confidence. They found water ice, organic molecules, carbon dioxide, and other materials consistent with comets that formed in the outer regions of other star systems. This data, they argue, is far more scientifically valuable than a pretty picture. Because while the public might be captivated by images, scientists care more about understanding composition, structure, trajectory, and origin. And in that respect, the observations of Three-Eye Atlas were highly successful. Third, the scientific community highlights the fact that interstellar objects are inherently difficult to study because they don't announce their arrival in advance. Unlike comets from our own Oort cloud, which we can predict and prepare for, interstellar visitors show up with little warning. By the time they're detected, they're often already on their way out of the solar system. This leaves astronomers scrambling to gather as much data as possible in a very short window. It's not a matter of not caring or not prioritizing, it's a matter of doing the best you can with the time you have. And according to researchers, they did exactly that with Three-Eye Atlas. They mobilized observatories around the world, coordinated observation campaigns, and collected as much data as the object's speed and trajectory allowed. That the images aren't magazine cover quality is, in their view, irrelevant. Science was done, knowledge was gained, and that's what matters. Now all of this sounds reasonable. It sounds like the kind of sober, evidence-based explanation that should put the controversy to rest. And for many people it does. Scientists and science communicators who understand the technical realities accept these explanations and move on. But for others, particularly those outside the scientific community, the explanations don't quite land. They don't quite satisfy. Because the gulf between what experts find acceptable and what the public expects is wider than it should be. And that gulf is where doubt lives. Part of the problem is communication. Scientists speak in the language of precision and qualification. They hedge their statements. They acknowledge uncertainty. They explain caveats. This is good science. But it's not always good communication. Because to the general public, hedging sounds like evasion. Uncertainty sounds like not knowing. And when you're already suspicious, when you already believe something might be hidden, scientific caution reads as confirmation of your suspicions. It's a tragic irony. The very qualities that make good scientists, rigor and carefulness, can make them unconvincing communicators to audiences primed for clarity and confidence. There's also the issue of accessibility. Much of the detailed response from the scientific community appears in academic journals, conference presentations, and technical blogs that the average person doesn't read. The explanations exist, but they're not reaching the people who need them most. They're siloed in spaces designed for experts, not for the curious public. And so the gap persists. The questions remain unanswered in the minds of millions, not because answers don't exist, but because those answers aren't being effectively disseminated. But let's dig deeper. Let's look at some specific responses from prominent astronomers and see how they address the most common concerns. One astronomer, in an interview, explained that the resolution limit for ground-based telescopes imaging 3i Atlas was approximately half a mile per pixel at best. That means any surface features smaller than half a mile simply couldn't be seen. The object itself was estimated to be only a few miles across, so at best, you'd see a handful of pixels representing the entire object. No detail, no structure, just a bright blob. And that, the astronomer argued, is exactly what the images show. Not because anything is being hidden, but because that's the physical limit of the technology. Another researcher addressed the question of why better space-based telescopes weren't used. She explained that observation time on telescopes like Hubble is allocated years in advance through a competitive peer review process. When 3i Atlas was discovered, there was a narrow window to request directors' discretionary time, a special allocation for urgent, time-sensitive observations. Such a request was made and granted, but the time available was limited. Hubble was able to capture some images, but they were constrained by the object's faintness and the short exposure times required to avoid motion blur. The result, she noted, was images that showed the object's activity, its coma, but not fine surface details. And that, she insisted, was expected. It was the predicted outcome given the constraints. There's no mystery here, she said, only physics. Yet another scientist took a different approach. He acknowledged the public's frustration, but argued that the fixation on image quality was misplaced. He pointed out that many of the most important discoveries in astronomy come from data that's completely invisible to the human eye. Radio waves, infrared, X-rays. The idea that a discovery is only valid if you can see it with your eyes is, he argued, a relic of pre-scientific thinking. We live in an age where instruments extend our senses far beyond their natural limits. And the data those instruments collect, even if it doesn't make for pretty pictures, is what drives understanding. 3i Atlas was studied extensively across multiple wavelengths. The data is there, the science is sound, and the fact that people are disappointed by the lack of a glossy photo is, in his view, a failure of science communication, not science itself. These are compelling arguments. They're grounded in expertise and experience, and they deserve to be taken seriously. But do they fully address the public's concerns? Do they explain why, in an age where we've photographed Pluto's surface, where we've captured the image of a black hole, where we've landed rovers on Mars and sent probes to the outer reaches of the solar system, we can't get a clear image of an interstellar object passing relatively close to Earth? Maybe they do. Maybe the technical limitations are genuinely insurmountable given the specific circumstances. But maybe, just maybe, there's a little more to the story than pure physics and logistics. Because here's the thing, science is done by humans, and humans make choices. Choices about priorities, choices about resources, choices about what to pursue and what to let go. And when those choices result in outcomes that disappoint or confuse the public, it's fair to ask whether different choices could have been made. It's fair to ask whether interstellar objects, given their rarity and significance, should be treated as the highest priority, deserving of whatever resources are necessary to study them thoroughly. It's fair to ask whether the scientific community, in its focus on data over imagery, is underestimating the importance of visual evidence in building public trust and engagement. These aren't attacks on science. They're questions about how science is practiced, how it's communicated, and how it serves the broader society that funds it. And that leads us to the next layer of this investigation. If the scientific explanations are insufficient, or at least unsatisfying, then what are the alternatives? What could be hidden, hypothetically, if something were being hidden? What scenarios, speculative as they may be, would necessitate the kind of caution and ambiguity we're seeing? Let's explore those possibilities, not as definitive truths but as thought experiments, as ways of understanding what people are thinking and why they're thinking it. Because speculation, when grounded in curiosity rather than blind belief, can be a valuable tool for probing the edges of what we know and what we don't, and that's exactly where we're headed next. Now we enter the realm of speculation, and I want to be absolutely clear before we proceed. What follows is not fact, it's not evidence, it's not proven. What it is an exploration of the possibilities that people are discussing, the scenarios that emerge when you take the available information, or lack thereof, and ask, what if? Because speculation isn't inherently bad. It's a form of creative reasoning. It's how we explore hypotheticals, test ideas, and push the boundaries of conventional thinking. The key is to label it correctly, to never confuse speculation with certainty, and to always return to evidence as the ultimate arbiter of truth. So with that understanding, let's dive into the most compelling speculative scenarios surrounding 3i Atlas and its mysteriously blurry images. Scenario 1. 3i Atlas is an artificial object. This is, without question, the most sensational possibility, and it's the one that captures the most attention. The idea is straightforward. What if 3i Atlas isn't a comet or an asteroid at all, but rather a probe, a craft, or some form of technology created by an intelligent extraterrestrial civilization? What if it was sent, intentionally or as a derelict, drifting through space, and happened to pass through our solar system? The implications of such a discovery would be staggering. It would fundamentally alter our understanding of our place in the universe. It would confirm, beyond doubt, that we are not alone, and it would raise 1,000 questions about who sent it, why, and what it means for humanity. Now, why would anyone believe this? What evidence, even circumstantial, points in this direction? Well, proponents of this theory point to several factors. First, the unusual behaviour of some interstellar objects. Oumuamua, the first confirmed interstellar visitor, exhibited an acceleration that couldn't be fully explained by standard cometary outgassing. Some scientists proposed that it might have been propelled by solar radiation pressure on a very thin, sail-like structure. While this explanation is natural, it's also consistent with the kind of light sail technology that advanced civilizations might use for interstellar travel. 3. Atlas, while behaving more like a typical comet, still arrived from interstellar space, a place we know almost nothing about. Could it be carrying technology? Could it be surveying star systems as it passes through? It's not impossible. Second, there's the argument from probability. The universe is vast, billions of galaxies, each with billions of stars, many of which likely have planets. The statistical likelihood that intelligent life has arisen elsewhere is, according to many scientists, quite high. And if intelligent life exists, and if it's more advanced than us, it might engage in interstellar exploration or communication. Sending probes to other star systems is something we've already done on a small scale with Voyager and Pioneer spacecraft. An advanced civilization with better technology could do it far more effectively. So the idea that 3i Atlas might be such a probe isn't purely science fiction, it's speculative science, grounded in plausible extrapolation of what we ourselves are capable of. But here's the critical question. If 3i Atlas were artificial, why would NASA hide it? What would be gained by keeping such a discovery secret? One answer is societal stability. The revelation that an alien probe has entered our solar system would be, to put it mildly, disruptive. It would challenge religious beliefs, provoke existential anxiety, and potentially cause panic. Governments and institutions might decide that the public isn't ready for such information, and that it's better to study the object in private until more is known. Another answer is strategic advantage. If the object contains technology, even defunct technology, it could be reverse engineered. Whoever controls that technology gains an enormous advantage, whether scientific, military, or economic. So there would be powerful incentives to keep the discovery quiet while attempting to retrieve or study the object in secret. But all of this assumes NASA knows for certain that 3i Atlas is artificial, or at least suspects it strongly enough to take such drastic measures. And that's a huge assumption. More likely, if there were any unusual readings or behaviours, NASA would be cautious, would study privately, but wouldn't jump to conclusions, because extraordinary claims require extraordinary evidence, and releasing information prematurely without ironclad proof would be professionally and institutionally reckless. Scenario 2. 3. Atlas contains or is composed of exotic materials unknown to current science. Maybe it's not artificial, but it's also not ordinary. Maybe its composition includes elements or compounds we've never encountered. Maybe its structure exhibits properties that don't fit our models of planetary formation or cometary evolution. If that were the case, NASA might be hesitant to release detailed images until they fully understand what they're looking at. because releasing images of an object that defies explanation would invite rampant speculation, and NASA understandably wants to provide context and explanation alongside any data they release. So they wait, they analyze, they theorize, and in the meantime, the public is left with blurry images and vague statements. This scenario is less dramatic than alien probes, but it's arguably more scientifically plausible. We know that the interstellar medium is different from the environment within our solar system. Objects that form in other star systems, around other types of stars with different chemical abundances and radiation environments, might develop compositions and structures we don't expect. If 3I Atlas turned out to be made of something truly unusual, it would be a major discovery, one that could reshape our understanding of astrochemistry and planetary science. And NASA, wanting to get the story right, might delay releasing detailed information until they're confident in their conclusions. Scenario 3. 3I Atlas is part of a larger ongoing phenomenon that NASA is monitoring but not publicly discussing. What if 3I Atlas isn't unique? What if there are multiple interstellar objects entering our solar system, more than we've detected or announced? What if there's a pattern, a trajectory, a commonality that suggests something unusual is happening? This is pure speculation, but it's the kind of speculation that arises when people feel information is being controlled. If NASA has detected multiple anomalous objects and is trying to understand the bigger picture before making public statements, that would explain the cautious communication. It would explain the focus on data over imagery. It would explain why individual objects like 3I Atlas aren't given the spotlight treatment. Because the story isn't about one object, it's about many, and that story isn't ready to be told yet. Scenario 4, the cover-up isn't about what 3I Atlas is, but about what NASA failed to do. This is the least glamorous scenario, but perhaps the most realistic. What if the blurry images are simply evidence of poor planning and resource allocation? What if NASA didn't prioritize 3I Atlas as highly as they should have, and now they're embarrassed? What if they missed the opportunity to capture clear images because of bureaucratic inertia or scheduling conflicts, and now they're downplaying the situation to avoid criticism? In this scenario, there's no exotic material, no alien technology, no grand conspiracy. Just an institution protecting its reputation by obscuring its mistakes. It's mundane, but it's entirely plausible. So which scenario is true? Honestly, we don't know, and that's the point. The lack of clarity, the absence of detailed images, the vague explanations, all of these create an environment where speculation flourishes. And while some of that speculation is wild, some of it is reasonable. Some of it asks legitimate questions that deserve honest answers. And that's why this conversation matters. Not because we need to prove that aliens are visiting us or that NASA is incompetent, but because we need transparency. We need institutions to recognize that the public's curiosity is valid and that dismissing it as conspiracy mongering only deepens mistrust. What could be hidden? Maybe something extraordinary, maybe something embarrassing, maybe nothing at all. But the fact that we're asking the question, the fact that millions of people are unsatisfied with the official narrative, that tells us something important. It tells us that there's a disconnect, a failure of communication, a gap between what people expect from their space agencies and what they're receiving. And closing that gap isn't just about better PR, it's about better science communication, better transparency, and a genuine commitment to public engagement. Because space exploration isn't just for scientists, it's for all of us. And when something as significant as an interstellar visitor passes through our neighborhood, we deserve to be part of the story. We deserve to see what was seen, to know what is known, and to ask questions without being dismissed. That's not too much to ask, and it's the foundation upon which trust is built. So as we move forward, let's consider what all of this means for the future of space exploration, for the relationship between institutions and the public, and for the values of transparency and accountability that should guide us. That's where we're headed next. Let's step back for a moment and talk about something bigger than 3I Atlas. Let's talk about trust. Let's talk about the relationship between scientific institutions and the public they serve. Because at the heart of this entire controversy, beneath all the speculation and technical debate, is a fundamental question. Do we trust NASA? Do we trust that they're telling us the truth, that they're sharing what they know, that they're acting in the public interest rather than their own institutional interest? And if we don't trust them, or if that trust is eroding, then we have a problem that goes far beyond one blurry image of one interstellar object. Transparency matters. It matters in government, it matters in corporations, and it matters, perhaps most of all, in science. Because science is built on openness. It's built on the idea that knowledge should be shared, that discoveries should be scrutinized, that data should be accessible to anyone who wants to verify it. That's how science advances. That's how errors are corrected. That's how breakthroughs happen, when information is hidden, when data is restricted, when explanations are vague or incomplete. The entire scientific enterprise suffers. Peer review becomes impossible. Replication becomes impossible. Trust becomes impossible. And NASA knows this. They know that their credibility depends on transparency. They know that public support, which translates into funding and political backing, is contingent on the belief that they're being honest. So why then does it so often feel like they're not? Why do we have situations like 3i Atlas, where the public is left with more questions than answers? Why does it feel like information is being controlled, filtered, selectively released? Is it intentional? Is it bureaucratic inertia? Is it simply a failure of communication? Whatever the reason, the result is the same: erosion of trust. And that erosion has consequences. When people don't trust institutions, they turn to alternative sources of information. Some of those sources are credible, many are not. Conspiracy theories thrive in environments where official narratives are perceived as incomplete or dishonest. Misinformation spreads when people feel they're not being told the whole story. And once trust is lost, it's incredibly difficult to rebuild. Because trust isn't just about believing what you're told. It's about believing that you're being told everything, that nothing important is being hidden, that the institutions you rely on respect you enough to be honest, even when the truth is complicated or uncomfortable. So what does transparency look like in the context of space exploration? It looks like open access to data. It looks like timely release of information. It looks like clear, understandable explanations for decisions and outcomes. It looks like admitting mistakes when they happen and learning from them publicly. It looks like engaging with public questions, even skeptical ones, with patience and respect. It looks like recognizing that the people funding space exploration, the taxpayers, have a right to know what's being done with their money and what's being discovered in their name. But transparency also requires responsibility from the public. It requires us to approach information with critical thinking, to distinguish between evidence and speculation, to understand that science is a process, not a collection of facts. It requires us to accept that not all questions have immediate answers, that some mysteries take time to unravel, and that ambiguity is sometimes unavoidable. Transparency is a two-way street. Institutions must be open, but the public must be discerning. Both sides have to hold up their end. Now, in the specific case of 3i Atlas, what would transparency have looked like? It would have looked like NASA proactively explaining, in detail, why the images were of the quality they were, not in response to public outcry, but as part of the initial release. It would have looked like providing a comprehensive overview of the observation campaign, including what telescopes were used, what challenges were encountered, what data was collected, and what images, if any, were clearer but perhaps not yet processed or released. It would have looked like acknowledging public disappointment and explaining why, despite that disappointment, the mission was scientifically successful. It would have looked like inviting questions and answering them thoroughly, rather than issuing brief, technical statements that left people more confused than before. And this isn't just about managing public perception, it's about living up to the ideals that space exploration represents. Because space exploration is, at its core, a collective human endeavour. It's not just NASA's mission or the scientific community's mission, it's humanity's mission. When we send probes to Mars, when we build telescopes to peer into distant galaxies, when we track interstellar objects passing through our solar system, we're doing it on behalf of everyone. We're expanding the boundaries of human knowledge, we're answering questions that have haunted us for millennia. And when discoveries are made, or when opportunities are missed, the public deserves to be part of that story. They deserve to share in the triumphs and to understand the setbacks. But there's another layer to this. Transparency isn't just about ethical obligation, it's also strategic. Because the more the public understands and trusts scientific institutions, the more support those institutions will receive. When people feel included, when they feel respected, when they feel like they're part of the journey, they're far more likely to advocate for continued funding and exploration. They're far more likely to defend science against political attacks or budget cuts. They're far more likely to inspire the next generation to pursue careers in STEM fields. Transparency, in other words, isn't just the right thing to do, it's the smart thing to do. And yet, we see the opposite happening far too often. We see institutions retreating behind walls of jargon and bureaucracy. We see defensiveness when questions are asked. We see a reluctance to admit uncertainty or error. And we see the consequences: declining trust, rising skepticism, and a growing divide between experts and the people they're supposed to serve. This isn't sustainable. If science is going to continue to thrive, if space exploration is going to continue to inspire, then the institutions leading these efforts need to do better. They need to communicate more clearly, they need to engage more honestly, and they need to recognize that transparency isn't a weakness, it's a strength. So as we think about 3i Atlas and the controversy surrounding its images, let's not lose sight of the bigger picture. This isn't just about one object, it's about how we, as a society, approach the unknown. It's about the values we expect from our institutions and the responsibilities we accept as informed citizens. It's about building a future where scientific discovery is a shared experience, where transparency is the norm, and where trust is earned and maintained through consistent honesty and openness. That's the world we should be striving for, and it starts with conversations like this one, with asking hard questions, with demanding better, and with refusing to settle for anything less than the truth. But transparency alone won't answer all our questions about 3i Atlas. What we really need is better technology, better tools, better opportunities to study these rare interstellar visitors when they arrive. And fortunately, that future is closer than you might think. So let's turn our attention now to what's coming next, to the advancements on the horizon, and to how those advancements might finally give us the clarity we've been searching for. Because the story of 3i Atlas isn't over, it's just beginning. Here's the good news. The future of interstellar object observation is bright. The tools we have today, impressive as they are about to be dwarfed by the tools coming online in the next few years. We're on the cusp of a revolution in astronomical imaging, one that will finally give us the capability to see distant, fast-moving objects with the clarity we've been demanding. And when the next interstellar visitor arrives, whether it's another comet, an asteroid, or something we can't even imagine, we'll be ready. We'll capture images that will leave no room for doubt, no room for speculation, and no room for accusations of cover-ups. Or at least that's the hope. So what's coming? What technologies are in development or already deployed that will change the game? Let's start with the Vera C. Rubin Observatory, currently under construction in Chile. This isn't just another telescope. It's a survey telescope designed to scan the entire visible sky every few nights, creating a constantly updating map of everything that moves or changes. Its primary mission is to detect near-Earth asteroids, supernovae, and other transient phenomena. But it will also be extraordinarily effective at detecting interstellar objects as they enter the solar system. The earlier we detect them, the more time we have to point our best instruments at them, to plan observation campaigns, to mobilize resources. Rubin Observatory will give us that early warning. It will ensure that the next 3i Atlas doesn't slip by with only a handful of blurry images to show for it. Then there's the James Webb Space Telescope, already operational and delivering stunning results. Webb is optimized for infrared observation, which makes it ideal for studying cold, distant objects like comets and asteroids. Its sensitivity and resolution far exceed anything we've had before. If an interstellar object like 3i Atlas were to pass through the solar system today, Webb could potentially capture images and spectra with unprecedented detail. We could see surface features, analyze composition with exquisite precision, and detect subtle activity that would be invisible to lesser instruments. Webb represents a quantum leap in our ability to study the cosmos, and interstellar objects are squarely within its capabilities. There's also the upcoming Extremely Large Telescope, or ELT, being built by the European Southern Observatory. With a primary mirror nearly 40 meters in diameter, it will be the largest optical telescope ever constructed. Its light-gathering power and resolution will be unmatched, allowing it to image faint, distant objects with clarity that was previously impossible. When ELT comes online, it will be able to resolve details on interstellar objects that are currently far beyond our reach. We're talking about seeing individual surface features, tracking rotation, and tumbling, observing jets of outgassing in real time. This is the kind of observation that will answer questions definitively, leaving no room for ambiguity. And beyond these specific instruments, there's a broader shift happening in astronomy toward rapid response and coordinated observation. The global astronomical community is recognizing that transient phenomena, things that appear and disappear quickly, require new strategies. Networks of telescopes, automated alert systems, and international collaboration are all being developed to ensure that when something rare and valuable shows up, everyone is ready to observe it simultaneously. This kind of coordination will be crucial for interstellar objects, which by their nature don't give us much time to act. The next 3i Atlas will be met not with scattered, uncoordinated observations, but with a unified global campaign to capture as much data as possible. But technology is only part of the equation. There's also the question of prioritization. Will interstellar objects be given the attention they deserve? Will they be treated as the high-priority targets they are? Based on the lessons learned from Oumuamua and 3i Atlas, the answer seems to be yes. The astronomical community now understands the scientific value of these objects and the public interest they generate. Future visitors will almost certainly be prioritized for observation by the world's best telescopes, and that means better images, better data, and better answers. Now, what about 3i Atlas specifically? Is there any chance we'll get better images of it retroactively? Could additional data be processed or released that would clarify what we're looking at? It's possible, but unlikely. The object has moved on far from the inner solar system and is now too faint and distant for detailed observation. The images we have are likely all we're going to get. But that doesn't mean the story ends here. Scientists are still analysing the data that was collected. Spectroscopic observations are being studied in detail. Models of the object's trajectory and composition are being refined. And while we may never see a clear photograph of 3i Atlas, we might still learn a great deal about what it was and where it came from. There's also the possibility, however remote, that 3i Atlas or objects like it could be visited by spacecraft in the future. Imagine a mission designed specifically to intercept and study interstellar objects. A probe equipped with cameras, spectrometers, and sample collection tools, launched and positioned to rendezvous with the next visitor. It sounds like science fiction, but it's being seriously considered. NASA and other space agencies have studied concepts for such missions. The technical challenges are enormous, requiring incredibly precise timing, trajectory calculation, and propulsion. But if it could be done, it would provide the definitive answers we're seeking. It would give us close-up images, direct measurements, and maybe even physical samples. That would be the ultimate transparency. No ambiguity, no speculation, just raw, unfiltered data. And here's what's exciting. The technological advancements I'm describing aren't decades away. They're happening now or within the next few years. Rubin Observatory will begin operations soon. Webb is already changing the game. ELT is on track to see first light this decade. We are right now entering a golden age of astronomy. An age where the tools match our ambitions. An age where the questions we've been asking for centuries might finally get answers. And when the next interstellar visitor arrives, we'll be ready. We'll capture it in stunning detail. And maybe, just maybe, we'll finally put to rest the doubts and suspicions that have plagued observations like 3i Atlas. But until then, until that future arrives, we're left with what we have. Blurry images, incomplete data, unanswered questions, and a public that wants more, that deserves more. So what do we do in the meantime? We keep asking questions, we keep demanding transparency, we keep supporting the science and the technology that will eventually give us the clarity we seek. Because the future is bright, but it's not here yet. And in the gap between now and then, we have to hold institutions accountable, stay curious, and refuse to accept easy answers when hard questions remain. The story of 3i Atlas is a story of missed opportunities and technical limitations, but it's also a story of what could be, a story of the incredible potential that lies just over the horizon, and that potential is what should drive us forward. Not cynicism, not resignation, but hope grounded in the knowledge that we're getting better, we're learning, and we're building the tools to unlock the mysteries of the universe. And when those tools are ready, when the next visitor arrives, we'll finally see what we've been waiting to see. We'll finally get the images that make all of this effort worthwhile, and we'll finally understand with clarity and certainty what these interstellar travellers are and what they mean for our place in the cosmos. That's the future we're building toward, and it's a future worth the wait. So here we are. We've walked through the facts, the speculation, the technical challenges, the claims, the responses, and the possibilities. We've examined this mystery from every angle, not to arrive at a definitive answer, because definitive answers require evidence we don't yet have, but to understand the landscape, to see where the questions come from, to recognize why people are skeptical, and to appreciate the complexity of studying objects from beyond our solar system with the tools and resources we have today. And what have we learned? We've learned that 3I Atlas is a genuinely difficult object to image, that the technical challenges NASA cites are real, that distance, speed, brightness, and equipment limitations all conspire to make clear photography nearly impossible under the circumstances. But we've also learned that those explanations, valid as they may be, don't fully satisfy public curiosity, that there's a gap between what experts find acceptable and what the general public expects, and that in that gap, doubt and speculation flourish. We've learned that transparency matters, that when institutions withhold information, whether for good reasons or not, people fill the void with theories. Some of those theories are wild, some are cynical, but some are thoughtful, grounded, and deserving of serious consideration, and dismissing them all as conspiracy thinking does a disservice to the legitimate questions being asked. Because asking questions isn't paranoia, it's critical thinking, it's the foundation of inquiry, and it's something we should encourage, not discourage. We've also learned that the future holds promise, that better tools are coming, that the next interstellar visitor will be studied with capabilities that dwarf what we have now, and that the era of blurry, unsatisfying images is coming to an end. That's something to be hopeful about, something to look forward to, because the mysteries of space, the questions about what's out there and where it comes from, those are questions worth answering, and we're closer than ever to having the means to answer them. But most importantly, we've learned that this conversation, the one we've had together over the course of this video, is necessary. It's necessary because space exploration belongs to all of us, because the discoveries made by NASA and other agencies are made on behalf of humanity, and because we, as the people who fund and support this work, have a right to understand what's being done, what's being found, and what remains unknown. We have a right to ask questions, we have a right to demand clarity, and we have a right to expect honesty even when the answers are complicated or uncertain. So where do we go from here? What's the takeaway? Well, the takeaway isn't that NASA is hiding alien technology, or that 3I Atlas is something extraordinary that's been covered up. The evidence doesn't support those conclusions. But the takeaway isn't that we should blindly trust official explanations either, because trust isn't blind, it's earned, and it's maintained through transparency, communication, and accountability. So the takeaway is this: stay curious, stay critical, keep asking questions, and keep holding institutions to the higher standards of openness and honesty, because that's how we ensure that science serves the public interest. That's how we build trust. And that's how we move forward together. Now I want to hear from you, because this isn't just my investigation, it's ours, and your perspective matters. Do you think NASA's blurry images of 3I Atlas are simply the result of technical limitations? Or do you believe there's more to the story? Do you think institutions like NASA are generally transparent? Or do you think they withhold information for reasons we're not told? Have you seen the images yourself? What was your reaction? Did they raise questions for you? Or did you accept the explanations provided? Drop a comment below and let me know. Tell me where you're watching from, what your background is, whether you're a space enthusiast, a skeptic, a scientist, or just someone who stumbled across this topic and found it fascinating. I want to hear your thoughts. I want to know what questions you still have, and I want to continue this conversation, because the more voices we bring into it, the richer and more valuable it becomes. This isn't about convincing you of one perspective or another. It's about exploring together, it's about thinking critically together, and it's about demanding together the transparency and honesty we deserve. And if you found this video valuable, if it gave you information you didn't have before, if it challenged you to think differently or reinforced your existing questions, do me a favor, hit that like button. Not for the algorithm, though that helps, but because it tells me that this kind of deep, thoughtful, nuanced exploration is what you want to see more of. And subscribe, because we're going to continue digging into topics like this. Topics that matter, topics that provoke curiosity and demand investigation. I'm not here to give you easy answers or sensational headlines. I'm here to explore the hard questions with you, and if that's what you're looking for, you're in the right place. Share this video with someone you know who's interested in space, who's asked similar questions, who's wondered why those images looked the way they did. Because these conversations need to spread. They need to reach beyond the echo chambers and the algorithmic bubbles. They need to be had in public, openly, with as many people as possible contributing their perspectives. That's how we move forward. That's how we build a culture of curiosity and accountability. And finally, let me leave you with this thought. The story of Three-Eye Atlas, like so many stories in science, is unfinished. The images we have are all we have for now. The questions remain. The speculation continues. And that's okay, because science is a process, not a destination. It's an ongoing journey of discovery, where each answer leads to new questions, and where mysteries are part of the experience. We don't always get closure. We don't always get the clear, definitive answers we crave. But that doesn't mean we stop asking. It doesn't mean we stop exploring. And it doesn't mean we stop demanding transparency from the institutions that represent us. So as you go forward, as you think about Three-Eye Atlas and the larger questions it represents, remember this. Curiosity is not a flaw. Skepticism is not cynicism. And asking hard questions is not disrespect. It's engagement. It's responsibility. And it's the only way we ensure that the pursuit of knowledge remains honest, open, and accountable to the people it's meant to serve. That's the standard we should hold ourselves to. That's the standard we should hold our institutions to. And that's the standard that will guide us toward the truth, whatever that truth may be. Thank you for being here. Thank you for thinking critically. Thank you for caring enough to explore this mystery with me. And thank you for being part of this conversation. Because without you, without your curiosity and your questions, none of this matters. Together we're stronger. Together we're more informed. And together we'll continue to push for the answers we deserve. The universe is vast. The mysteries are endless. And the journey has only just begun. Let's keep going. Let's keep questioning. And let's keep demanding the clarity and honesty that will illuminate the path forward. I'll see you in the next one.